Well, hello everyone. Today I'm hoping to go through the answers to the last question set number 4, which is regarding the exercise of options, American options, when there are dividend payments involved. The important thing for you, I think, is that you should try to read the lecture notes of the last lecture carefully, because a lot of the clues actually are all in there. Now let me go to question 1. Now this is a well, it's put call parity. So you're long a short-term call. So you long a call 3 months and you're short a put 3 months. So you are basically, so here you are long a forward for 3 months, and then here you are short a call for 6 months, and you are long a put for 6 months. So you are short a forward for 6 months. Okay, so now the way you can look at this is, so here you are long from 0 to 3. So here you're long, and then from 0 to 6 you are short. So when you add them up, what you have actually is, you have, if this is the time now, you have a forward short position from 3 months from now to 6 months from now. Okay, that is your exposure. For the first 3 months, you are actually hedged. Now the definition of rho is what happens when interest rates go up by 1%. How does that actually affect your position? And you have to remember that the forward is actually equal to use the simple version. Okay, so forward is equal to the spot times the interest rate multiplied by time. So you can see that if you have a long position, then you kind of want interest rates to go up, because when interest rates go up, then your forward will go up. Now that's if you're long, okay? But here, so I already said you have a synthetic short position, so you're actually short, okay? Now how much are you short? Well, it depends, because you are actually short just for 3 months, okay? And then so rho, the definition of rho is 1% times the strike times the actual time period, the t here, okay, which happens to be a quarter, because it's 3 months, okay. So that 1%, and the strike is 100. So 1% of 100 is just $1 multiplied by a quarter, okay, which is 0.25. But I said you are short, okay, so it's actually, that's why the last D is the right answer. The interest rate here doesn't actually feature in a rho calculation, okay. It is, whether it's 6%, 8%, it is in fact just, the increment when it goes from 6 to 7, what happens, okay. Okay, that's question 1. Now this is, I think, when the option is European, so you don't really have a choice what to do. Now the next one is somewhat more interesting. This is when the option is actually American style, okay. And the position that you have is actually similar to the one before. So you are still, just to copy this this diagram down here, you can call that a diagram. Okay, so here you are long, between 0 and 3, and between 3 to 6 you are short. So you have a synthetic position. You have a synthetic short position between 3 months and 6 months. Okay. Now in the previous question, the answer is you are short 0.25. Now you can see from this formula that I quoted you. Okay, the rho is equal to the 1% is 1%. It's just constant. Strike is also constant. So this 1/4 here actually represents the duration of your position, and from 3 to 6 months is 3 months, which is a quarter of a year. Now, a similar logic applies here. So you are definitely short. So the answer would either be C or D. Now, why is it not D? Because there is a chance that your option may well be exercised somewhere before. You don't know that. I think there's not sufficient information in this question, okay? But it will not definitely, it cannot just be 0.5, it can be shorter, okay? If there is more information which indicates that the option may well be exercised right here, okay? Then obviously the rho would be smaller, okay? That is why C is the correct answer. Now for question 3, which option has the biggest rho? I guess for a clue on that, you actually can refer either to the lecture, or you can refer to my the last tutorial file, where I also I provided the rho diagram for a call option and how it actually evolves as a function of the strike price. Let me just get there. So it's a little further down. Hold on a second. So you already have this file. So recap on early exercise. Oh, here we go. Okay, recap on rho. And now I don't want to waste your time here explaining in detail why these diagrams are the way they are. In fact, if you really want to know, now these are diagrams for the call, the rho of a call and rho of a put. And if you really want to know why they look like this, all you got to do is imagine the rho, which is this one, for a call, this for a put, and how it changes when K changes. Okay, and of course when K changes, so the T doesn't change, okay, but the ND2 inside will change. Okay, so I don't want to explain to the final detail, but it goes like this for that reason. Okay, for me, this is, I think it's my favorite diagram in option trading world, for the simple reason it's not symmetric. I like it because when it's not symmetric, you know, I start asking why, and I find this fascinating. But in any case, for a call option, so this is a diagram of a call rho for a call when it's the, I think this it's strike 50. Okay, so you can see that, and I mean when they plotted this diagram, I don't know what assumptions they made on interest rate and dividends. So obviously that has some effect on the forward price. But in any case, you can see that the row of a call should be at a maximum when it is slightly in the money. Now I know that's not the case with this diagram, okay, but the row of a call is not maximum when it's at the money. Please just be a bit careful how you interpret this graph here, because we are actually holding the strike price we are holding the stop price to be constant. We are saying if the stop price remains at 50 and you have a whole load of options, call options, with a strike ranging from 10 to 90, so that's a lot of options, okay, in which case a call option with a strike of around 45, let's say, okay, and if your spot price was 50, so this option is actually 10% in the money, slightly in the money. That is when the row is at the highest. And now if you look back at the question, let me go to the question now. Then the question. So there's an at the money option here, okay. There's a slightly in the money, or you could say near the money, slightly in the money. You shouldn't. Maybe we should not say near the money in this case, because near the money could be, a 105 call, okay, but it's slightly in the money. So here we should be precise, okay. This one is deep in the money, and in fact, this one is slightly out of the money, okay. So these two are both near the money, but here we need to make a finer distinction, okay. So even when you are near the money, it is the in the money, the ITM side, okay, that I am looking at, and this is the option which has the maximum interest rate sensitivity. I actually, if you read carefully my notes, my tutorial slides, in fact, I went on to explain. I tried to give on this page the reasons why these graphs behave the way they do. Okay, you can even differentiate row with respect to the strike price, and then you get a second derivative, and then you can determine where actually the maximum point would occur, and so on. But that's an exercise for your intellectual curiosity, which you probably don't have time for right now. Okay. Question number 4. Okay. Now here we start discussing put call parity, or I guess the violation of put call parity and early exercise of American options. I guess I can say a couple of things here. First of all, before you even dive into, okay, let's just do this. Okay, I'm just listen to me. Okay, before you even dive into these exercises, you have to take a step back and ask yourself, okay, what is it that we are trying to do here? Okay, now you know that if you own a call option, which is a wonderful thing, you have to pay for it. Okay, it is somewhat similar to owning some stocks and having a put option. Okay, now I know there are interest rate dividends. Let's just forget about those for a moment. Okay, so when you have a call, when it goes up, you make money. When it goes down, you don't. It is a little. It has similarity to when you own some stocks. So when it goes up, you make money. When it goes down, you are protected by the put. Okay, now it's not exactly identical, but it's similar. And when you have a put option, okay, which is also a wonderful thing to have, it would be as if you are short the market. So when it goes down, you make money, but when it goes up, you're in trouble. Okay, so what do? If you are short the stocks and you have a call option, okay, then when the market goes up, the call option is going to protect you against your losses from your short position. Okay, now you know that. Okay, you know all this. In fact, the second equation is simply taking the S to the other side. All the discussions that we have here regarding whether you should early exercise or not revolves around some simple assumptions. Okay, now let's talk about the exercise of an American call to start with. Okay, now the assumption number one is you already have this call. You are the proud owner of a call. Okay, and you are wondering whether you should exercise this call and replace it with this position here. Okay, now that is the heart of the argument. Okay, this is the essence of the last lecture. Okay, it is a comparative argument. It has nothing to do with your view on the market or how it's going to evolve over time. Well, no, it is related to that, but it's got nothing to do with your market outlook. It is simply a cost-benefit analysis of what happens when you ditch one and take on something else. Okay, now you have to think like that. Okay, and likewise for a put position. Okay, you are already the proud owner of the put, and you actually intend to keep this put until expiry, but you may actually exercise and replace with this position. Of course, you replace it with an American. And here you replace it with an American put. Okay. So, like I said, now, why would you do that? First of all, okay. The answer is if these American options actually do not pay any dividends, actually you wouldn't. You know from Derivatives 101 that with an American option, you would never exercise it early if there are no dividend payments. Let me digress a little bit here. One of the favorite interview questions for traders, if they have even just a little bit of experience, is, well, first, they sometimes ask a trick question, which is, when would you consider to exercise a European option if there are dividend payments? Okay, so first of all, European, okay, and there are dividends or no dividends, okay, and then there are American options with dividends and without dividends. Okay, now, so sometimes it's a trick question. When would you exercise a European option when there are no dividends, or when there are dividends? Now, of course, this is a trick question. You can't exercise European options until the end. Okay, so it's kind of a stupid question, but if you know nothing about options, this is the time when it will show. Okay, and you're going to start babbling about, it depends on your view on the market. In fact, I remember there was one time, there are, when you go for a job interview, I have said this before, there are some questions people ask, and when you give a wrong answer or a rather silly answer, that response that you give is likely to be fatal, which means you won't get the job. And an example of that would be if they ask you, okay, let's forget about European options because it's not applicable, but that can be a tricky question. Let's focus on American options. So if someone asks you, when would you exercise an American option that doesn't pay a dividend? So this box here. Okay. So the right answer, of course, is you never would. Okay. Now here is when things start to get interesting, and this box here is the one that we almost exclusively will be focusing on for now. Okay. But anyway, I have heard answers like, when would you exercise an American option which has, or an American call, let's say, okay, which pays dividend? Now, here is a question which would demand a more substantial answer because there is an answer to it. But you know what? I have heard someone would give the answer, well, it depends on your view on the market. Now, that is a really stupid answer, okay? No, it doesn't. It's got nothing, absolutely nothing to do with your view on the market, which is what I spent the last 5 minutes trying to tell you. It is a comparison, it's a comparative argument. I have a call. It is an American call. Do I replace it? Do I exercise that and replace it with this or not? Okay, so that is the decision here. Now, why would I exercise a call and then replace it with, the stock and a put option? Well, you would do that. Well, first of all, if you exercise a call, what are your benefits? Your benefit is that when you exercise a call, you're going to buy the stock, and if there is a dividend forthcoming, you will get the dividend. Okay? And if you're going to replace it, so on the right-hand side, this is the replacement. If you're going to replace it with the package on the right-hand side, so here's your benefit, okay? So what are your costs? Well, your cost, first of all, is that you have to borrow the money to buy the stock, okay? Not at the stock price right now, but at the strike price, okay? So it's the interest on the strike. You have to borrow the money. So we assume that you are running a trading desk with zero financing, okay? So everything, all the cash you need to borrow, and all the cash you receive, you get interest on that. So here you have to borrow, and you're going to pay interest, and also you have to pay premium on the put. Okay, so that's your cost on the right hand side. Now, the moment D is bigger than I plus P, you will exercise. Okay, and of course, when a call option has some time to run, so this is the time now. Okay, this is maturity, and this is the time when they pay the dividend. Okay, so the dividend remains the same, but you would want to exercise it right before, because that's when the interest cost will be lowest. Okay, and then your dividend is the same, so this gap between your benefit and your cost will be maximized. Now, maybe you're wondering, well, what about the cost of the put? Well, the thing is, the assumption here is that you assume that to be constant. Now, I know it's not constant. I'm sure 0.01 second your reaction is, hold on a second, it's not constant. I know it's not constant. In fact, if all else being equal, it's likely to be smaller, okay, because of time decay. Now, even if it's not constant, it doesn't really matter because you actually can hedge the whole thing as if it is constant, or you can hedge the delta anyway. Okay, so the price movements, the delta impact would not actually be an influence on you. Okay, but what you're doing is, all right, you already have a call today. Okay, and you have an incentive to replace that if by doing so you receive a dividend, a whopping big dividend. Okay, but then you have to borrow money and you have to buy a put option. Now, looking at it from here, of course, you don't know what the put price might be here. Okay, but if you were to hedge at least the delta, okay, then you can lock in the movement in the put option because of the delta movement. Now, maybe you're wondering, well, what about the gamma and the theta? Okay, well, they will cancel each other out, meaning that if you're going to buy a put option, okay, so here it will be cheaper. Okay, you buy a put option here, so compared to today, okay, so P0 or PTD, it's cheaper, but then you don't get as much gamma revenue from that. Okay, so it's all good. In any case, my point to you is this. Okay, take a step back and just try and remember that you are looking forward to this dividend. You know when it's coming. Okay, you know that this interest rate cost will go down every day over time, and so would this P. Okay, but the assumption is that you just hold P constant. So I mean, you don't have to replace it today. You already have a call. Okay. Now the logic of the put is somewhat similar. Okay. Now the if you exercise a put option, what happens? Well, if you don't have any stocks, you actually have to borrow the stocks. You put to somebody, and they give you the money. So your benefit is that you are going to get some money and you're going to earn interest on that. Okay, you're going to earn interest when you put that money in a bank account. Okay, the problem here is that now you don't. Now you have to go and buy a call option. Okay, so you need to pay the premium for the call. Okay, I run the risk of confusing you. So because I put P and little p up here, but this should be premium for a call. Okay, now as long as the interest that you receive is bigger than the call price, okay, you will exercise and replace it. And of course, if you do it as soon as possible, okay, that is when you maximize the interest that you get. Okay, so it is, the way I think about it is a little bit like if you want to drink some orange juice, okay, and then there are two ways to do it. One is you buy orange juice, and then the other way is you buy some powder, and if for some reason, when you add water to the powder, it becomes exactly the same orange juice, exactly the same, okay, but it's cheaper. I know that's impossible, but let's pretend you can, okay, then you would do it. Why wouldn't you do it? Okay, so this is a comparative argument. Okay, now with that in mind, I think these questions now become very simple, and let's take a look at question 4. So you have a call, which is a strike 50. Maturity is 1 year. Share price is now 60, so it is in the money. There's a dividend payment halfway through. The put is worth 80 cents, and interest rate is 2% per annum. Now, how would you tackle that? In fact, it's kind of hard for you to do this question because the answer is already in bold, so it would prejudice your judgment. But anyway, you can see in brackets as dividend is bigger than interest until expiry as put. What does that mean? So you have a call which will expire in 12 months, okay, and the dividend is actually 250, and if you were to exercise that halfway through, okay, then you need to borrow $50 because that is how much it will cost to buy one stock, and you need to borrow that for 6 months, and because the interest rate is 2% per annum, so you're going to be paying 1%. So your interest cost is going to be 50 cents, and your put is going to be 80 cents. Okay, so you are looking at a comparative advantage actually of $1.20. So yes, you will exercise the call in 6 months, okay, assuming all else is the same, okay. Now, so like I said, yeah, you might be thinking, yeah, the share price can go everywhere, okay, but you can hedge that, okay, as if it's frozen in time and the share price cannot move anywhere. Well, it's not frozen in time because time is ticking away. In fact, time is precisely the parameter that is ticking away. Okay, so the answer is B for question 4. Question 5. Okay, now look at the previous call. The put has the following. There is a corresponding put to it. Okay. And the put delta is minus 10, okay, and then you have the following position. So you're long 1,000 puts, you are short call, so you're long puts and you are short call, so you are actually short, okay, and then you need to hedge that synthetic short position, okay. So the question is, what actually is your delta? Okay, so here your long puts, you are short delta, you are short call, you are also short delta. Now, if you are short 1,000 puts, and the delta of each of them is minus 10, so that is minus 10,000. Okay. Now for the call option, and here's the twist. Okay, so since this call is exercisable and it will be exercised early, okay, the delta of that is actually 100 or minus 100 as it were, okay, so that makes it 100,000. Okay, so when you add up the two, you are actually short delta to the tune of 110,000. So in order to hedge that properly, okay, you need to purchase 110,000 shares. All right. Now question 6. Again, revert to the previous question. If we are non-assigned for 40% of our position, this is so you are short the call, and in fact, then you go back to question 4, because question 6 referred to question 5, which refers to question 4, where the call is deep in the money, and here is calculating the delta. But here the question really is, well, suppose you have this position, so you were short 1,000 call, and the call is in the money in 6 months' time, and they actually forget to exercise on you, okay, then what actually happens? Well, it's very simple. You look at the actual benefit, Okay, if they were to exercise on you, then just immediately prior to the dividend payment, then the benefit is $2.50, and the cost is 50 cents on the interest, 80 cents on the put option, which means you have a net gain, or the counterparty who is long the call has a net gain of $1.20 per option. Okay, now if they forget to exercise, then they don't get that $1.20 benefit, and their loss actually is your gain. Then your benefit will be $1.20 multiplied by 400 shares. Sorry, 400 calls, which you then multiply by the contract size. So that is equal to 48,000. Okay. So this is part one. So part two will be in another file.